Hello everyone, and thanks for joining me here. In this video, we're going to look at different ways of calculating IRR for the example that we just looked at and solved by hand. And just to remind you, here's the example. It was 6 different alternatives, and we analyzed them using incremental rate of return analysis to find the best investment alternative. And since this example was special in a way that the amount of investment and the amount of salvage value for all of these alternatives were the same, there was a shortcut to calculate IRR to simplify our manual calculations. But in any way, for any kind of cash flow, you can calculate IRR in Excel very quickly. And here I'm going to show you those couple ways of doing that. So here I listed all the alternatives and sorted them out from the smallest initial investment to the largest initial investment. And the first way to calculate IRR is to use the rate function. So if you type in rate, that function is going to help you to calculate IRR, and it's going to need a few arguments. First one is number of periods, and if you remember in this problem, number of periods was 10, so I'm putting in 10. PMT is the annual return, and annual return here is 1500. Present value is negative 10,000. And lastly, future value is the salvage value that we have, and that is 10,000. So if I'm passing those in using the rate function, I can get the internal rate of return. And for this problem, it was 15%, as we already knew. You can copy this calculation across, and it will calculate the internal rate of return for all of these alternatives for you. If you didn't have the equal salvage value in initial investment, that function is going to perform just fine, and it's always usable. The other way that I want to show you, it's a great feature of Excel spreadsheet, is using goal seek in Excel. So we know that IRR is the interest rate at which present worth is equal to 0. Right? And we used to do this calculations using these tables in the previous problems, where we calculate present worth at all of these percentages to see where exactly present worth becomes equal to 0. One of the easier way of doing that is to have a formula for present worth, and I'm going to put in that formula for all of these alternatives. Starting with alternative C, present value, if it needs to be calculated, it is using PV function, and PV function needs the rate, and I'm going to use this empty cell here as the rate, because later I want to use this cell in the goal seek capability of Excel. So I want to pass in this rate that later will be found. And then N per is the number of periods. We know it's 10. PMT is the annual return. So I'm going to pass in negative 1500 here. For future value is 10,000. I'm going to pass in negative 10,000 here. And we also have the initial investment, so I'm going to add that in at the beginning to the PV function. So what happens here is D5 is the initial investment. It's already in present time, and this PV function calculates the present value of the uniform cash flow that we have plus the salvage value. At what interest rate? At this interest rate that we're going to find. So at this time, because that cell is empty, it's going to calculate it at 0%. But what I'm going to do is I'm going to calculate IRR, and I already know that IRR is the percentage that make my present worth equal to 0. So I'm going to let Excel search for that percentage for me in order to make this cell equal to 0. And if you go to Data tab, under What If Analysis, there is a feature, it's called Goal Seek. So click on that Goal Seek. And here what I want to do is I want to set a cell, in this case present worth cell, equal to 0 by changing the IRR cell. And if I hit OK now, Excel is going to search through so many possible values for this empty cell in order to make the present worth equal to 0. So I'm going to click on OK here, and you can watch what happens here. And as you can see, it converges to a percentage, and that is 15%. I can do this for all of these alternatives here. Just as a demonstration, I'm going to do that for alternative B as well. And here I'm going to click on Goal Seek again. This time I'm going to set this cell, present worth of alternative B, equal to 0 by changing IRR. And now clicking on OK, it's going to find that percentage for me. And if I increase the decimal places here, you will see that they're going to be equal to exactly 25%. It's going to be the same for all the other ones. I'm just going to calculate them here for you. So this was 2 different ways of calculating IRR, either using the rate function or using the goal seek. You can do that with Excel. But what I'm going to do, I'm going to calculate the present worth of all these alternatives the same way that we have been calculating them using the PV function. And as a demonstration, I'm going to do that for alternative C. So present worth of alternative C will be the initial investment plus present value of rate is 1%. Number of periods 10, PMT is negative 1500, and future value is negative 10,000. Again, I'm passing negative values because I want to get a positive return from the PV function. And I'm going to lock some of these cells so I can copy down my calculation across the rows. You can press F4 on those and it will lock them. Now if I copy this down, it's going to calculate. As you can see, right on 15%, present worth is equal to 0, and this is what we already knew. So I'm going to fill out this table. So here we are, the completed table, as you can see, and here you can see where the present worth sign changes from positive to negative, which is exactly where the IRR is located. And here I graphed all the alternatives here, and on the right hand side I only graphed the more important alternatives. Well, as a financial analyst or as an engineer or as a manager, it's important to provide more insights in the analysis that you are doing. Instead of coming out with a binary decision of whether you got to make that investment or you don't, the upper management a lot of times want to know more about the details, and providing graphs like this is very helpful because it shows that at different percentages, at different MARR values, minimum attractive rate of returns, how your decision changes. And here you can see that at different ranges of MARR, the best choice or the best investment alternative changes. And this is very useful when you're doing such analysis for upper management, because it gives them this perspective and insights, because a lot of time MARR changes, and you want to know how does your investment of choice change. For example, here, alternative A is the best alternative in a very small range of MARR, as opposed to alternative F, where it's the best alternative in a larger range of MARR. So that means alternative F is less sensitive to the choice of MARR. So make sure to be prepared for making such insights and graphs when you're analyzing investment opportunities using incremental rate of return.